Hello there and welcome. In this episode, we continue working on our server, and in the previous episode, I told you that we're basically done with the API client, but there is one method that we still need to implement, and I'm talking about this GetAllUsers method. And I also explained to you that the reason this will not work is because it uses the same GetRequest method like, for example, our getUserById, and this getRequest will always return one user data, right? It will get the response and then it will simply convert it into this user data object. But if we want to use GetAllUsers, we obviously want to get several users or a lot of users. We don't want to get one user. So this will not work. So in order to fix this, all we need to do is create a very similar method that instead of getting one user, it will get multiple users. Another thing we also need to change is the callback, because at this point, the callback will only return one user data. And this is not enough because when the callback is triggered in the game manager, for example, over here, it only gives us one user and then we can only use the data of this one user. So we will have to create another callback that will be for multiple users. So before we do this, we will create some kind of class that will be a wrapper over this user data. Because you may think that you can simply do list of user data and then it will somehow automatically convert this list to user data. This will not work. So this wrapper will be very simple. First of all, it's going to be a serializable, and then it's going to be a public class. It's going to be named user data wrapper. You can also name it user data array or something that will be easier for you. It's going to have a public array of user data. Okay, so this is the only thing that we want. We basically want to provide some kind of class that will contain all the different users, and we are going to use this one instead of one user. So now we don't really want to change the functionality inside. Obviously, we can create some kind of generic get method that will have some kind of bool that we're going to say if it's true, we want to get multiple users, and then we're simply going to do some kind of if over here. Of course, you can do that if you want to save some space and you don't want to create more methods, but I think it's much simpler to just create another get request method that will be used when we want to get multiple users. First of all, we're going to go over here, and instead of using the get request, we're going to create some kind of method or use a method that is going to be named get request multiple, okay, or get request multi. So it will basically be used when we need to get multiple objects or multiple users. Or let's call it get request multi-user. This will be much more understandable. And now we need to generate this method, but because it's going to be very similar to our get request, we're simply going to copy this entire get request. We're going to copy and we're going to paste it over here. Okay, and now we're simply going to rename it to get request multi-user. So we have this get request multi-user, and this will basically be called when we want to get several users. So over here, the only thing that will be changed is this line, okay? All the different things will stay the same. Of course, we also don't want to create a user if we don't find the data, because this is just a list of users. So this is not relevant, okay? This will happen inside the regular get request, not inside the get request multi-user. But everything else will be the same, and the only difference is that we want to change this line over here. So instead of converting our response into user data, we're going to convert it to user data wrapper, and we're also going to set it into a user data wrapper. And we can also rename this to user data array or list. And of course, change it over here. But as we can see, our callback will still not accept this because it's of type user data. So this as well, we need to change to user data wrapper. And now it's going to receive this and it's going to get invoked. And it will basically convert this response into a user data wrapper. Now, this is not enough. And this is just because of the way our JSON is structured. And as I told you, we are not dealing with JSONs, but still a GET request will receive some kind of body, and this body will be structured as a JSON. And that's why we need to convert it from the string into a JSON and then into this data class. So this will not work. We need to add some strings over here to actually manipulate the data that we're going to get. So to do this, we need to do something like this. We're going to create a string over here, and we're going to say that it's going to be a users object, and then we have these escapes just so we can put these quotation marks inside. We put this and then we close the string, then we add our response, and after the response we do the same thing but we close the bracket. So if you look at this together, we are simply creating a JSON and we're placing our JSON that we get from the response into this JSON. So we're basically nesting our JSON response into another JSON. Because inside the response, we're going to get a list of users. But in order for this to be converted into a wrapper, we need to place this list of users, this array of users, into one object. So we have one users object, and inside we have a list or an array of responses. And this is exactly the structure of the user data wrapper, right? We have this one users object, and inside we have an array of user data. So this is just a small manipulation we need to do in order to be able to convert our response into this wrapper and then into a list of users. As we know, we also changed the callback. So when this callback is going to be invoked, it's not going to actually invoke anything inside the game manager because this is not the same callback, okay? So we also need to fix this. First of all, after this is done, we're going to scroll back over here because as we can see, this callback is not going to be accepted into this GetAllUsers because this callback is also using a user data. So over here, we're going to change it to user data wrapper. And now our GetAllUsers method will use this kind of callback. And now everything is implemented. So when we use getUserById, we are using the regular getRequest. But when we use GetAllUsers and we want to get a list of users, we're going to use this getRequestMultiUser, and we're going to use this user data wrapper as a callback. Because over here, we want to return one user, and over here, we want to return a list of users. Now, if you have some other logic in the future that you require to get more data, and it doesn't really have to be just user data. Maybe you have a list of enemies, or maybe a list of location data. So if you want to get multiple objects, you will use getRequestMultiUser. If you want to get only one, you will use the getRequest. Obviously, you will probably have to change the callback type because if it's not a user data and it's some kind of environment data, so you want to change the callback itself. But you will also have to change the getRequest because at this point, we are converting it into a user data and not into any other class. So this getRequest is only meant for user data. And if in the future you want to have more objects, you will probably not use this getRequest, or you will create some kind of generic getRequest that will get different callbacks based on the object. Now, again, this is not a tutorial about how to design your own game and your own application. This is just an example of how to create these requests to the server, because we're using this kind of logic each time we communicate to any server, right? Not only a custom server. So if we communicate with Firebase or maybe other databases or some kind of service, we are always using this web request format, and then we get the response and we convert it. So this has nothing to do with a custom server that I'm teaching you. This is just the regular way to talk with an external API or an external service, okay? And in our case, it's a custom server. So again, you should change your own logic based on your game and based on your use cases. But at this point, if you have user data, you can use this get user by ID and get all users. Now we need to go back into our, let's first save this and let's go into our game manager. And over here inside the game manager, we need to use the new get all users method, right? Let's say you have a list of leaderboards or something like that. You want to be able to load a list of users and populate this leaderboards. Now it's up to you if you want to do it inside the game manager. Maybe you have another scene with the leaderboards, so you can call this method inside that scene. But just for simplicity, I'm going to call it here as well. So all we need to do is call our API client, get all users, and that's it. So at the beginning, when we just start the app, it will get a list of users. Now we also need to provide a callback, but as we know, this callback that we have over here is not the same callback. It uses user data, not user data wrapper. So what we are going to do is create another callback. So we're going to copy this and paste, and we're going to rename this to on data received multi-user, okay? And over here, we're going to change it to user data wrapper. Now you can keep this as it is, but you can see that it's not going to work because we have multiple users inside of this save data. So we can rename this to users data or something like that. And now we're going to remove this because it's not going to work. So we're going to check if the user's data is not null. We're simply going to loop over this list. So for each user data in user data or users data dot users, right? Because we have this users array inside of this wrapper, right? This wrapper contains an array of user data. So we are going to get this user's data and we're going to loop over it, and then we're simply going to print all the users. Now, obviously, if you want to use this callback to actually populate your UI, you can simply do it over here. You can say for each user, maybe have some kind of prefab, right? Var my prefab, and then instantiate this prefab into some kind of content. Maybe you have some kind of scroll view, right? So maybe you have some kind of prefab for the leaderboards, and then you want to instantiate a prefab for each one of these users, and then you're going to use your prefab set data, and then you're going to set the data of the user. So you're going to have a list of prefabs, and each one will have its own data with its own user. Obviously, this is just an example, but for simplicity's sake, we're going to print this to the console. So data ID, so this is the user ID. And data score, and this is the score. Okay, so we're simply going to print all the data, but of course, we can also rename this to user And again, you can use this to actually populate your UI. So this callback is going to be called to get data. Okay. So this callback is going to be triggered when we use it and when we invoke it inside the GetAllUsers. So this is the one we're going to use. Okay. Now the GetAllUsers only needs a callback because we don't want to get a user by ID. So we don't need to get or provide a user ID. We only need to provide the actual callback. You can see the parameter. It only wants this callback. So inside the GetAllUsers, when we call it, we go to this get multi-user. It's going to get a list of users. It's going to convert them into this wrapper, and then it's going to send this wrapper into the callback, and it's going to invoke the callback. And then it means that when this is done, it's going to invoke this callback, and this callback is this one. And then we're going to get a list of users, which is this wrapper. And we can do whatever we want with this. Again, if you don't remember why we use a callback, it's just because these are web requests and we don't know when a web request will be complete because it depends on a lot of things. It depends on the server, if the server is fast or slow. It even depends on your own internet connection. So if you have a very bad connection, it may take some time to get the response. And we don't know when this response will be completed, so we cannot just use it. We need to wait until the response is done. We need to make this asynchronous. So that's why we use this callback for these web requests, and we only invoke it when we get the data. And then it's going to be called not over here, not in the awake, right? We call it in the awake, but we don't know when the callback is going to actually be executed. That's why when you start your application, you should have some kind of loading screen to wait until this data is back and until this callback is actually called. Otherwise, the user will open the leaderboard screen and he will see that the list is empty, and only after a few seconds, the list is going to be populated. So it may give like a bad user experience. So you may want to wait a bit until the response is actually there. Or maybe you want to keep the old list of old users and then only update this when you got the response. Again, this is really up to you. Now, everything is basically done. We can test this and it should get the list of users. Obviously, we only have one user because we only used this device. Now, of course, to make this work, we need to update the public IP again. So let's go into our server and let's get the public IP. Again, if your server is always running, the public IP will not change. Only if you stop it and start it again, the public IP will change. And again, there are ways to keep your public IP. For example, we have elastic IPs. You can see over here, it's basically a way to get a permanent IP, and then it will not reset each time you stop the server. So we have this elastic IPs. There are other workarounds, for example, a failover server that will always run and get the current public IP and just update it. There are many ways to do this. So now we're going to save this and we're going to run the game. So let's start. Now we can see that we have some kind of problem that it did not get the list of users, but it also did not get the user by ID. So we know that it's not really related to the changes that we did with GetAllUsers, because even this one did not work. And we saw in the previous episode that this one should work, right? So there was some kind of problem, and we can see cannot connect to destination host. So if you get this kind of error, cannot connect to destination host, it means that we simply cannot connect to this server. Now, double check if this is the actual public IP, but as we can see, it is the same public IP. So something else is not working. So let's connect to our server, and I'm already connected. And we know that when we try to connect to these endpoints, we basically want to connect to the database manager. Now, of course, we can do this from the URL. So if we use our public IP, let's just copy this entire thing. And we're going to use the GetAllUsers. So even from the browser, we can see that this is not available, okay? The problem is with our actual server. So because we are trying to reach into our database manager, we should see what is going on. And a way we can check this is by simply using sudo systemctl and then check what is the status of our service. So our service is database manager.service. And we can see that for some reason, it failed to start our database service. We can see that currently it's failed, so it's not active, right? And we can also see over here, this is the log. So we can see that this happened a bit before when we started our server, then it failed to start the database service. So it means that the problem was that it did try to start the service when we started the server, right? It did try to start the service, but it failed. Now, to fix this, at this point, we can simply use this and say start, or even better, enable and then start, and it will start the service, and then we are going to be able to access it. Now, what is the reason that it failed? Now we can debug this together. So for example, let's go into our database manager service. So we can simply edit this file. Let's just do this. Okay, so sudo nano etc system database manager service. So this is our service unit file, and here we can find all the configurations for the service. It uses this Python file to actually execute the logic. It uses this working directory, and everything seems to be correct. So if you have a problem, this is a good place to look. But as we can see, everything is right. We don't have anything unusual over here. So if you need more data regarding the reason why a service is not running, you can also check the logs of the service. And we can do this with journalctl. Now, I talked about this in a previous episode, but we're going to check this together again. So let's exit. And we can do sudo journalctl -u for unit, and our unit, our service, database manager.service. And we get a lot of logs, and over here we can see some more information. So we saw that at this point in time, we tried to start the service, but it failed. Okay, we can also see this result exit, and we saw this when we did the status of the service. But we can get more information, and it tells us that we cannot connect to the MySQL server. Now, this is weird, right? Because we know that our MySQL server should be running. And it makes sense because at some point inside this script, we try to initialize the database. And for this, we try to access into the server, into the MySQL server, and it simply crashes, right? So this is the reason the service is not running. So now we can exit, Control-C, and we can check for the containers that are running. So you can do docker ps, and we can see that the container is running, right? The MySQL container is running, but it was started 3 minutes ago, and it makes sense. It started when we started the server. But think about it. if the container starts when we start the server, and then the database service is also starting when we start the server, maybe this database manager service tried to access the container before the container was running, okay? So it's not really a bug or maybe some kind of error. This is just a poor design because we did not consider this when we created both of these services, right? Imagine you start your server and both the container for the database and this database manager service, they both start at the same time. And maybe it takes a bit longer for the container to start, and this service is already running and it tries to get information from the container, but the container is still not ready. And then it crashes, okay? So we understand the reason now, and the way to fix this is by simply creating some kind of delay between the execution of the container and this database manager service. So we need to make sure that this service is only starting to run after the container is up and running. Now, there are multiple ways we can ensure this, but one way is to edit our unit file, and inside the unit file, we simply need to say that we need to wait for this service, and only when this service, the Docker service, is ready, only then start the database manager service, okay? So let's see how it's done. We're going to click up, and edit our unit file, and inside, we're going to say over here that we want this to start after network target, okay, after we actually have internet connection, but we're also going to do this space and we're going to specify Docker service. So we want to make sure that the Docker service is up and running, and only then we're going to start this service. We also want to specify requires Docker service, just to make sure that it actually depends on the Docker service. And now it will wait until the Docker service is up and running and all the containers are running, and only then it will run this service, okay? But maybe we want to be double sure that it's going to happen, so we can create some kind of restart for the service, and then it will basically restart the service in 10 seconds. We can see this restart always. It means that it will always restart when we start the server, but we can also specify restart seconds 10. So it will wait 10 seconds until it actually starts this service. Now, this may be useless if you already have this, but this is just a way to actually create some kind of delay in other situations. So now we also created this small delay of 10 seconds, but we also require the Docker to be up, and this will probably prevent this problem. So we first make sure the container is running, and only then we try to access it from this service. So let's go back, Control X, Y to save, and enter. Now we're going to stop our server again and check if it solves the problem. So now the server is back up, and before we try to access the endpoints, we should check if the service has started by itself. So we're going to do sudo systemctl status, and we're going to check the status of our database manager service, and we can see that it is running. Okay, so everything is now fixed. The container will first start, the MySQL container, and only then our database manager will try to access it. So this is a fix for our situation, but you may encounter other situations like this in the future when two services are depending on each other, and then you want to make sure one executes first and only then the second one. And it's very similar to Unity. Sometimes we have a script and another script, and one script is using the other one, but one starts in the awake and one starts in the start method, and then we cannot reach it because it's still not active. So we need to make sure the order is actually correct. This is what we have over here. So now that we see that it is running and we didn't even have to connect to it, we could just know that the server is starting and that this should work. We can change the public IP. And we can see that we get a list of users. But obviously the point of all of this was to see if our actual application can do this, because we changed the code over here. Oh yes, of course, we need to change the IP here as well. And now we start the game. And we wait. And actually we got this straight away. So you can see this. This is the device ID, and we have this pipe, and then we have the high score. So we actually got a list of users. Now obviously this is not a list, but this is the only user that we have. So you can see GetAllUsers, and we get this one list of users, which is the ID and then the score. And this is exactly what we got over here, because this is what we wanted to print inside the callback, right? For each user, print the ID, pipe, and then score. So now we can see that GetAllUsers is working. And obviously, if you have this installed on more devices, each device will have its own user that will be created in the database using its own device ID. And then it will give you the actual high score of the specific device. And that's basically all for the logic inside the API client. Now, I still remind you that this is not a tutorial about to create a full game. This is just about our custom server. All of these web requests are pretty generic. We do them for every kind of API and service, not only for this custom server that we created. We just need to understand that eventually the response comes as a plain string, and this can be a string of some kind of data class like this one, right? We can see ID and score because this is a data class, this is an object, but we only have one object. If we had more objects, it would be a list of objects, okay? And if it's a list of objects, we cannot just transform it into this one user data because it's simply one user data. But for this, we created the multi-version, so we convert the response, which will be a list of users, into an actual wrapper, which is an object that contains an array of users. And this way we can get the full list. And if you have more logic, more use cases in the future, then you should probably add them over here or on the server side inside the database manager script and do this. So in the next episode, I want to show you how we can actually access our database container, our MySQL database container, and check different information about the database itself, because at this point we can only use these endpoints to fetch the data that we decided to have inside the database manager. So we query the database using the database manager, but we can also do this straight from a third-party application and see the structure of the database. So in the next episode, we're going to download an application that we can use to connect to our database and basically see different information inside. We can also do different queries. Okay, we can, if you want to implement some kind of logic in your code. So before you do this, you can test around with different queries inside the database to see what it returns. and then you can use this data inside the database manager. And maybe we're going to do something the same. But that's all for this episode. Thank you for watching. Please subscribe. You can also become a member of the channel and get access to our private Discord server and get other perks. You can also leave a like. So see you next time.